Alright, so here's the old carrier and the pinion. I wanted to go over them a little bit before I take the bearings off and start putting the new ones on to the other pieces. So we'll look at the pinion first. Take the bearing off. This seems okay. There's some rust on here that may have come from when the axle was sitting around for like 4 years before I did anything to it. The race seems fine, so I don't know, maybe some water sat in there. So that's the outer bearing. There's the crush sleeve. Don't need that anymore. I have new ones. Looking at the inner bearing on it. So it seems okay. Spins. Fine, no problems. However, when I look at the race, something happened there. All of this, just this weird band of the part of this just corroded. I'm not sure, been worn away. A couple other little spots in it. Hopefully you can see it on the camera. I don't know what did this. It's not rusty, so I don't think any water was sitting in it. And with the way that the axle was sitting, water would have gone down to the outer bearing, not the inner bearing. So I don't know, but what I suspect is that this race might be older than this bearing. I think someone worked on this axle before. They took the pinion out, popped this bearing off, put a new one on because they had some problem, but I think they might have left the old bad race in there. And the other thing that gives me that impression is when you look at the carrier. Where did it go? There. So when you look at the carrier, on some of the teeth, right there, it still has the yellow mustard paint that you smear all over the teeth when you're putting in new bearings and rebuilding a rear end. This is so you can make sure that you have your pinion depth correct, that the pinion and the ring are engaging correctly, and it's still there on a couple of these teeth. I don't think this is a factory thing. I think someone's been in here and swapped out some bearings, but they left the race in because they didn't want to punch that out. There's also some weird discoloration there on this ring. I don't know what caused that. You know, otherwise it seems alright. It spins freely. There's nothing, I haven't seen anything wrong with the bearings on the carrier. I'll have to somehow get in here and spread apart the spider gears to get them out. That'll be fun. I think you have to make like a tool to do it. In these clips, I was planning to talk about how much I could notice the wear on the old Pinion compared to the new Pinion. But when I was recording this footage, I noticed that the two Pinions are actually different. The Pinion on the left is the old one, and the Pinion on the right is the new one. They're not the same part. The Pinion on the right, which came with the gears I bought from the person on Facebook Marketplace, that's for a 2011 and up 9.75 inch rear end. Ford made a change in 2011 where they started using, instead of, I think it's a 1.9 inch inner diameter inner pinion bearing, they went to a 2 inch inner diameter inner pinion bearing. So all the other, the pinion bearings that I bought, they would not slide onto it. They wouldn't fit. So I had to order a new pinion for this setup. This is the crush sleeve that would be used on that 2011 and up one. It's a completely different crush sleeve. So it's a whole different setup. Well, even though the pinion is wrong, there's still work I can do to it. Underneath this bearing, there's a shim that I need to get out and put onto the new pinion whenever it arrives. So I gotta get that off. And this bearing is a press-on. It's a press-on bearing, so I need to get it off there. Hopefully one of these will fit. Sure, why not? Not long enough. Alright, went out and I got longer bolts from Ace, so now I can actually use this thing. I feel like just tightening this is actually starting to loosen the bearing up.
Yeah, this might actually just be working.
Yeah. Itself. Is it loose now, or is it? Wait a minute. Oh yeah.
Did not even need the press.
That's awesome.
All right. And all of that for this that I need to save. A bearing splitter that actually splits bearings. Yeah.
Look how sharp it is.
Yeah.
The other one we had wasn't even sharp.
Alright, now we're going to lose all of those. Yeah, we're going to find these like 3 years later.
Oh, like the last time?
Yeah. Be free. Little bearings.
Use your strong hand.
Oh, I got they're going everywhere. Alright, I got them. All right, hold on to your butts.
No, I'm good.
Easy peasy.
You got the right tools and you use heat. And it's already cold out here, so this shit's cold anyway.
It sucks, like, this is the end you can't really get on the press very well.
Yeah. I'm glad you had this tool, because I had to press it out with.
I think we had to, like, cut it off.
Woo! Woo! That's hot. And that random piece of aluminum was perfect.
Yeah.
Very hot.
Yes. Like, you'll feel it break loose, and then it starts to turn a lot easier. Cool. Alright, so next I need to get the spider gears out of here so I can get the old clutch packs out. And to do that, apparently what we have to do is there's like big spring washers that hold these two, the big spider gears. So you need to press them outwards, and you can kind of then walk the other spider gears out. So I'm gonna try to make a tool so I can press on them. I have some long threaded rod, some jam nuts and washers. So hopefully I'll be able to make something that I can tighten nuts in two different directions and spread this apart. Alright, ow, that's still hot. Anyway, I took the threaded rod, welded on one of those coupler pieces to it. This way I'll be able to hold onto this end with a wrench while I turn the jam nuts in opposite directions to spread apart those spider gears. Okay, I think I finally got it set up correctly now. So, I put one of the axles into a vise, so I can slide the differential onto the axle. This way, I'll try to spin the whole carrier. This one gear will stay because it's on the axle. The other ones will spin, and the spider gear should walk out. My vise is not strong enough to keep it fully clamped and not turn, so I've got some scrap metal wedged into the lug studs over there. And then I got the thing that spreads the spider gears third on the other side of the carrier. So it's pushing the two spider gears apart that have the clutch packs behind them. And then hopefully I should be able to just turn this and the two other spider gears will fall out. Alright, they're already pretty loose actually. So let's see if this works. There we go. Now it's turning. Alright. Spider gears are starting to come out. Yeah, there's one right there, almost. So there is like a bevel washer behind these two spider gears. You want to catch that. Almost. They're so close to coming out. Hey, stop moving. Ah, there we go. All right. Spider gear and yeah, spider gear washer or shim thing. I don't know what it's called. There's no clip that holds it on, so it just sits in there. And there we go. With its bevel washer shim thing also. Cool. So in the vehicle, I've heard that it's easier in vehicle because you can have something jamming the other wheel, you know, like you can have someone holding with a pry bar or just get a piece of metal, put it in the studs and have it press against the concrete or something. And then you just somehow turn this, or I've also heard you turn the axle, you take one axle out, you turn the other axle and they'll crawl out. There's other videos you can watch online. So this tool I made a while ago. It's was a Harbor Freight breaker bar. The head broke off of it, so I cut it, cleaned it up, welded it to a piece of bar stock, and I made two holes in here. This way I can make other attachments to go onto this. Like this is for the pinion flange, and it would just bolt on there. Or I could just use the bolts and pry things like this. All right, now I can finally get these other two spider gears out. I'm gonna loosen up the spreading tool that I made. Huh. So, wow, that's already loosened up quite a lot. So there's spring washers, really big spring washers behind these. So that's why you have to spread them. That's why they're now starting to come together. All right, shouldn't be anything else holding these in. But there's the gear and the clutch, gear and the clutches, and the steel pieces that go in, the steel pieces that go in between the clutches. Wow, that's like nothing there anymore. Then there is the spring. So it was in there like this. So it was domed out towards the inside. That goes in there. And I think that's everything in that, on that surface. Yeah, looks like it. Okay, so that's one. Put that in a butter tub. And then the second one. Second one. Cool. Now a completely empty housing. Okay, so the way these things are set up, here's one of the ones we just pulled out. You've got that spring washer, one steel plate, very worn, followed by clutch plate. So clutch, steel, clutch, steel, and you can see how it's the steel plates that spline in to the spider gear. Clutch, steel, clutch, steel, and then you're just down to the gear. Nothing else there. So the new kit that I got, so I did get these spider gears. I got these spider gears, so I have all four spider gears. These spider gears came with the new of that bolt for the pin and two of those bevel washer things. Those spider gears. Okay. The kit also came with some things I'm not sure what to use for. There are some shims. These appear to be, well, they'll work on those. Okay, so they're probably to shim, maybe if you're housing wares, I'm not actually sure. It also came with these clips. And I don't know where these go. Maybe this is something to do with the non-True Track one. All of the new clutch packs over here, I've been soaking them in oil, as you're supposed to. 75W140. Now, before I tore anything apart in the differential, I made sure that the new spider gears that I have, they do spline onto the axles. So, I believe these are correct. Alright, now I'll start stacking up the components. So, on first, we have steel. Okay, important detail. So, some kits may not come with the spring washers. Mine did, so I'm going to use the new ones. These are the old ones. I'm not going to reuse them. But a little key detail is that the last steel spacer you're going to put on, the one that the spring washer pushes against, it is not splined. Just a round hole. So keep that in mind. First you put a layer of steels, and then you put your nice new friction material. Yeah, compare that to like the old ones. Like, second layer of steel, friction, and more steel, friction, steel, final friction material, non-splined, non-spring washers on, and then the spring washers with the convex, yes, the bulging side goes against the steel. Alright, this will be kind of interesting because I have to, just for now, just set that right there. There's nothing to spline onto yet. Get one of my new springy doodles with all the clutchy majigs. So all the clutches have tabs on them. You just need to line them up so you can drop this in. Sitting there for a second. Don't you do that. Take two. I'm going to hold the gear this time. There we go. Sit. Stay. I'm going to go ahead and take the spring and just lay it in there. It's just you. Go in there. There you go. All right. They're both more or less in there. Stay. Do I have to get a clamp? Take rag. Shove it in there to hold them apart. Okay. Don't drip on my floor. Oh, you gooey bastard. All right. Let's stick tool in there first. Okay. All right. Now I have to try to get the other two spider gears in. This will be interesting. So you kind of just have to, again, putting that spacer thing on here, like set them in, and the other one from the other side, and you have to somehow evenly walk these things back in there. Okay, so update. I've been having a bitch of a time getting the spider gears and the washers in the carrier, even with the old parts, the old spider gears. And I think I've had a bit of a rage-inducing breakthrough. So here's the old clutch pack from one side. It is 0.762 inches, 0.76 inches, let's say. Here's the new clutch pack. And that 0.76 is not going to fit. This is 0.81. So 0.05 inches thicker. Now it's supposed to be thicker because you have new material, but from what I've read, it's supposed to be like a few thousandths, not 50 thousandths thicker. God damn it. I mean, even just visually looking at them, like, the new stuff is almost like the thickness of one of the steel plates, wider than the old stuff. And now this would explain the shims that were put in here. Now, I assume that they put shims in there in case maybe it's something catastrophic that had happened. You neglected this for a long time. Maybe the housing had been worn down, or maybe one of these gears had worn down, and you needed to make it thicker. I didn't anticipate that the shims were to make it thinner, because I don't see why. Like, obviously they had all the measurements, because they knew how to make the teeth and the friction material. Like, why not just make it a drop-in part? Why do I need to do fitting on my end when I've already bought it and I'm going to put it in? Like this stuff here, these plates, just make them whatever the thickness they're supposed to be from the Ford factory, not whatever sheet metal you found and stamped these out of. All right, now that I got the carrier back together, I can actually put the ring gear onto the carrier. I'm going to go over it with a file, or both surfaces with a file, just to make sure there's no burrs there that might tweak it as I press it on there. So the instructions say to line up, start with 3 bolts to kind of align it. Get that one started also. All right, so it's aligned now. Now I'm gonna take it to the press. All right, I finally get to use the press on this. Hey, look at that. All right, you can reuse the bolts for the carrier and the ring. You just have to put blue Loctite on them. Torque on these is 111 foot-pounds. There we go. One. Sweet. Done. Once you get the internals of this thing sorted out, everything else just starts going along much more smoothly. So next I'm going to be putting on the bearings that go on the ends of these. These bearings do have to be pressed on. They go like that. And you don't need to have the race on there, but this is why it's important to keep the old races. If you were to get them off, that's good. If not, you'll have to find something you can use here. You don't want to be pressing on like the bearings themselves. You don't want to have the race there and press on the race, which then pushes down on the bearings, the rollers. You want to be pushing on the inner race to slide this on there. So I kept the old race. This will work for that. You can probably make something. There's maybe a socket that big somewhere, or it's a piece of tube steel that you then put like something on top of. There's no shims that go underneath these. It's just the bearing just goes straight on there. It still spins freely, so I'm not pushing down on the bearings. Okay. There we go. I hear the wood crackling, so one bearing seated. So in preparation for the next steps of this rebuild, I've gone ahead and purchased a second of the inner pinion bearing. It's the same Timken part number. I only have the one race. That's fine. The race is going to stay inside the axle. The reason for the second bearing is that this is going to become a setup bearing. The way you make one is you kind of grind out the inside of this so that it's no longer a press fit. When you go to put it on the pinion, it will freely slide all the way down instead of needing to be pressed on. And the reason for that is because you need to be able to get the pinion depth correct without ruining the press fit of the one bearing that you are going to use. You're going to press this on last after you figured out everything else. And everything else you're going to figure out is shims. When I took the old pinion apart, there was a shim underneath the bearing. This one's going to go onto your new pinion. It may work, it may not. If it doesn't, the kit for the bearings that I got also came with a pack of shims, so we can get the pinion depth correct. Spindle sander would work great for this, but I don't have one, so drill it is. Okay, the drill method was taking way too long, so now I've got a boring bar set up in the lathe. This is fine. Oh yeah, maximum safety. Okay, well that took a while and a lot of grinding, but I finally have the slide-on setup bearing ready. And just to be very clear about why I'm going through all this effort and why I spent the extra money to get a second bearing that I then ground out to make into a slip fit, is that if you do need to use different shims to get your bearing depth or your pinion depth right, that means you're going to be pressing this bearing on and off of the sleeve a lot, or on and off of this pinion a lot. And that will wear out the press fit. See, like again, right now, if I take the new, this is gonna be the final assembly bearing, it won't go all the way down. It's a press fit. I'm gonna have to heat this up and probably put this in the freezer overnight and then press them together. So if you do need to swap swap shims out, and this is coming on and off a lot, it will wear out these two surfaces, and then you won't have a press fit anymore. And the reason you want to press fit is because, like right now, if I just slide this on here and I spin it, yeah, it seems fine. It's being a bearing. But when you have everything together and it's all bolted tight together and you have load on the bearing, you see what's happening? It's not the rollers that are turning. It's the inner race is spinning against the pinion. And that will destroy all this differential work you've been putting in. So you want a press fit, not this slip fit that will rub metal on metal like this. I realize that may not be easy to see because it's all shiny metal. So there's a paint dot. If I put just a little bit of load on here, and again, that's the race. It's gonna wear against the pinion, and that will destroy all of this. All right, so now I need to drive in the races for the pinion bearing so I can then do the pinion depth setup. I was able to find drivers that fit the outer pinion bearing race, but I don't actually have one big enough for the inner. This is pretty big. The kit that I have only goes up to 81 millimeter driver, and that's not big enough for this. So I'm going to find something else. There's the bounce. It's seated. Okay, so that's the outer race seated. Yee. Sweet. Okay, wow, it's taken a while to get to this point, but it's finally time to start putting in the pinion to set it up to check the pinion depth. So to do that, I've got the factory washer that was there, or spacer shim thing. My setup bearing that slips on. Old crush sleeve. And the new bearing. Okay, I'm pretty sure that's supposed to just be a slip fit there. Like if I look at the old pinion, here's the old bearing, it just plops. There is a slight lip right here. Where it's like they machined it down and they stopped right here. There's like a line in the splines and they can just get slightly bigger after that. It's fine, it's fine, it's fine, it's fine. I'll just gotta tap this thing on. It's fine, it's fine. It's not fine, but it's fine. All right, there. It's a slip fit now, as it should be. So the reason this bearing, it can get away with being a slip fit is because unlike the inner pinion bearing, the inner race on this bearing gets pinched. On the one side, you have the crush sleeve. On the other side, you have the pinion flange itself, which is splined to the pinion. So the inner race on this bearing is pretty mechanically locked to the pinion itself. That's not the case with the inner pinion bearing. Yeah, the backside of the race, inner race, it sits on this surface, but there's nothing pressing down against it from the inside. So the inner part of it does not get pinched by anything. So that's why that one's a press fit, and this is just a slip fit. Quality control, come on. Just machine it all the way down. Put the whole pinion thing through. Outer bearing, which now slips on. There we go. Oil slinger. Get on there. Pinion, what are you? You're the flange. Okay. Okay. Flange. Now I'm going to start the nut. I'm going to run it down with the actually 1.1/8" socket. Just to take up the slack. I'm not really going to try to torque this down. Oh, still plenty of slack. Nope. So to check the preload on the pinion bearing, you're going to need your socket and a beam style torque wrench. Not a clicky one, a beam or a dial gauge one like, I think like Snap-on makes those or something. So you need one of the beam style ones because you're going to turn it, you're going to read where the arrow is pointing. Now the spec for this is 15 to 19 inch-pounds. 15-19 inch-pounds. Yeah, one problem with these beam style ones is they pretty much only come in 1/4-inch drive, and my socket is a 1/2-inch drive, so you have a whole bunch of adapters. We're going for 15 to 19 inch-pounds. And right now we're at 5. This is the used sleeve, crush sleeve. I need to tighten this down some. A hair over 20, so I'm gonna back it off a little bit. You can back off when you're doing this setup, but not when you're doing the final assembly. Okay, now comes the fun part where I get to shove this heavy thing back in here without dropping any of the braces or the shims. So far, God, this is heavy. I'm just using the factory shims to see how this fits. Alright, you. Time to go back into your home. This shim on the driver's side is not cooperating. That race is getting tweaked. Alright, so the factory shims are too thick to go with this setup. I don't want to try to force everything in there and get things jammed. So now it's time for me to turn to the thing that I've been dreading during this entire process, and that is the shim pack. Looks like there's already like a set in here. Like there's 2 distinct sets. .342, .252. Driver side, 0.281. So let me try. Oh, these things are all stuck together. So that's all the little shims that are all stuck together with this, I guess, like cosmoline-like substance. 0.33, 0.325, 0.281. Okay, yeah. Too thick. My goal is to first try to get a little bit smaller than the driver's side one. I'm trying to go for this thick one that's on here. That I want to use as few shims as possible, just so there's less stuff to like drop and fall apart. And my God, this is stuck together. Get! Okay, there we go. All right. Man. So how thick are you? 258, 285. Let's try that. So I dropped it in here with the shim packs again. Factory passenger side, that 0.25, whatever it was, measurement shims on this side. It went in fine. Check this out. Barely anything there. We might be golden. I'm gonna get my dial gauge but I'm hopeful about that. It's gonna torque to 77 foot-pounds. Got the dial gauge set up. Spec is 8 to 12 thousandths. So I am at 2. Too tight. Okay. All right, so I need not the pinion, the carrier, ring gear to go that direction to loosen up this backlash. Why can't I just run that? No. Do it just back. A couple attempts later, 6. A little tight still. Okay, after like, I don't know, 6 attempts at this, I'm pretty much right at 8. So that is good enough for me. That's where it's gonna stay. Alright, well I was gonna paint the gears to check the wear pattern, but the yellow paint that came with the kit has kind of, well, it's not really flowing. Okay, I took some of the lithium grease, mixed it in with the gear paint that seemed to wetten up the gear paint again, so now I'm actually going to try this stuff on the teeth. Alright, let's try that. Alright, so yeah, that helped get a much clearer pattern. So what we can see, this is the drive side we're looking at. So what you can see is that there's this kind of this like dome shape coming up from the bottom, from the, I guess that's called the root. So unfortunately, this is one of the unacceptable patterns. Really, you kind of want like an oval in the middle. It's more important to get it centered this direction than it is this direction, but you want an oval shape, not this half dome coming up from either the bottom or the top. So what this means is the pinion is too close, so I need to put a thinner shim in there. Which means I gotta pop the carrier back out. Take much stuff apart. Hope I got some more shims. Fun! Alright, I need to find a thinner shim. There's the factory shim. 0.034. 34 thousandths. Alright, that's too thick. Here's the collection of shim that came with the kit. And I'm not really sure how much I need to shrink it down. These two here may be the thickest. So that's 0.016. I'm gonna go with just one of these and see what happens. And now the pattern shifted kind of up into this area here. So I'd add a little bit more of the thickness of the shims to get it to go kind of more in the middle. This is getting old. All right. Yank that off. So this is factory shim 0.036. This is about half the factory shim's width, 0.017. So I'm gonna try to go somewhere in between these two. So now I gotta find some combination of this shim and some of these other ones that give me a little bit thicker. 0.227? I like that. I'm gonna go with that. This is really close. Like, again, if I was putting this in some kind of like a beater truck that I don't care about, I might just leave it like this. I think what I want to do is I want to see a little bit more like fuzziness in the paint on the very bottom, like the root side down here. On new gears, the drive side is the main side to focus on. So I think I'm going to take just a hair more out of the shim, just a few thousandths out. Yeah, here's the coast side, and here you can kind of see there's some more fuzziness towards the root of these patterns, and that's what I want to see on the other side. The combination that I'm going to go with now, about 0.22, 0.25. I think I found the shims I'm going to use. So the wear pattern on the drive side is, it's more in the center between the face and the root. You can see there's fuzziness on the bottom and the top. It's not like a clean cut like line like in some of the other shim patterns that I tried. It is up here kind of towards the heel, I believe is what this side is called. But according to directions, the position of this between the heel and the toe is not important, or at least not as much as important as the face and the root position. So this is one of the acceptable patterns in the directions for the gears. So yeah, that's what I'm gonna go with. Time to take this thing apart and put the press bearing in there and new crush sleeve, and then it'll be done. Yeah, then I can get on with my life. All right, now that the backlash is set right, and we've got the pinion, I got the pinion depth right with all the shims, I can actually now start doing the final assembly. For the most part, the carrier is fine. I have to focus on the pinion. First, old crush sleeve. Come on, get off there. Goes away. Setup bearing gets set aside. I may use this on another future build sometime. I have to take the still press fit bearing and push that on. So I'm gonna go take that to the press. And then I need to get a new crush sleeve to go with it. Make sure that your pinion shims are in place. Press fit bearing, gonna go on there. I've got a tube here that's going to sit over this and push against the inner race of the new bearing. Oh, where did the handle go? I'm losing my mind. All right. Still spins, so here we go. Alright, so I did pause a couple times and I took it over to the table to kind of hammer it or tap it to make sure it's going on straight. So it's like it's going on straight now. Yep. Alright, I think that's on there. So I hear the crackling of the wood. And here you go. Pinion, bearing, shims. All together now. So, pinion, bearing, new crush sleeve, and hopefully for the last time, that goes in there. Steps on this end are going to be pretty much the same, but a little different. Pinion is there. The outer pinion bearing goes in. The oil slinger goes in. Now here's the first change. The pinion seal. I need to put this in. I'm going to put some RTV, spread that blob around. The seal. There we go. Take the pinion. That's still kind of greasy there. Pinion flange. Alright. Kind of slide in there for right now. Kit came with some thread locker stuff. I assume this is for the pinion nut. How do I open this? I'm just peeling it. Let's put some of that, a nice amount of that cherry stuff right there. Take new nut. Start to thread her on there. Okay, and now we're done. No, we're not actually. Now comes the really fun part. Gotta crush this thing. All right. All right, got some bolts. I'm gonna thread into this pinion flange plate tool thing. Excuse me. How the hell? Okay, so apparently a 1/2-inch drive adapter, you can take a 15mm socket and put it on backwards. I swear I'm mentally okay. I'm alive. I'm awake. I'm good. No, I'm probably not. I've been working on this on and off for a week. I'd like to stop. Still a lot of slack. Okay. I think that brought me close enough. Now that I can use the breaker bars. Still no preload on that. Now we're really getting into tightening that. Still slack. Wow. Bit of place. Now I gotta go small steps. So I do not want to overshoot this. That's most likely going to be nothing, but I'm still going to check it. Nothing. The goal is 20 inch-pounds. This nut does look like it's polishing up the threads. Not stripping them, but like cleaning them up. So it must be like a locking nut. Which is why it's taking so much effort. It seems like I'm being overly cautious. Again, if you don't want to overshoot this, you gotta take it back apart so you can put a new crush washer, crush sleeve in there. You can't back off once you have to hit the 20 and you can't back off. Okay, starting to feel something now. Okay, that's about 10. It's very small steps now. Alright. That's like 18. A very small amount more. Okay, there we go. Felt a nudge. 19. Good enough. So you can see what I'm seeing. A little bit of a stiff breakaway, but then it's at about 20 as I rotate it. Inch-pounds are up here. Yeah, so it's at like 19. I'm not going to try to go any higher with that. Yeah, I lied. I nudged it again, and now it's at like a nice 20. Now that the cover is sealed up and the gasket makers had time to dry, it's time to start adding in the fluids. I'm going to go through this sensor here. This hole here is for the sensor that measures the pips from this tooth wheel. I believe it's for the ABS stuff. First up, a bottle of Ford friction modifier. This is for the differential, the clutches and the limited slip. And man, this has it's a potent smell. It stings the nostrils. Put the whole bottle in. That is the forbidden Listerine. That was totally the color of Listerine. All right, just get all that in there. Stay. Oh God, that is formidable. Now, the actual directions from Ford say not to fill it all the way up until it starts coming out the drain hole. You want to fill it up until it's like an eighth of an inch or below the drain hole, but everyone fills it up till it comes out the drain hole anyway, and this is also reassembled and dry. So I'm just going to fill it up till it comes out the drain hole. So I want to make sure that when it starts moving around, there's oil, sufficient oil everywhere. I spent way too much time on this for it to not have sufficient oil. I think it takes 3 of these bottles. Maybe like 2.5 or 2 1/3 or something. Alright, let me know when it starts to dribble out of that hole. Oh, I sort of saw it. It's getting real close. I can barely see the level just through the threads. Oh wait, there it is. It's touching the threads. It's filling up the threads. Slowly. It's on the last thread. And there it goes. Full. Plug goes back in. The plug does have a magnet on it too, so you should clean that off when you have this thing apart. Get in there so you stop leaking on my floor. There we go. Okay. Click. I have no idea if this sensor actually works or not. It came in the axle when I got it, but I'm gonna put it back in here anyway, just so that it closes up the case. And if anything happens, when I'm moving it next time or giving it to someone, it's not gonna spill out of there. So far, it looks like nothing's leaking out of the axle seal, pinion seal. God, words. I think that's all dry down there. I also replaced the breather fitting for the tube. So as it gets hot, air inside there is going to expand. This lets it out. When it's in the truck, there's a rubber hose that goes all the way up and kind of hangs up underneath the bed somewhere, so the air can get in and out, but water can't get in it. So I put a new one of those in. All right, one final test to finish this off. If I lift up on this side, the other side moves up as well. That means the limited slip is working, which means this thing is done, which means I can sell it, and I can move on and go work on something else, like this. That'll be fun. Thank you for watching.